Today we're going to solve equations that have variables on both sides and learn some tricks to deal with fractions, so hopefully that makes things a little bit easier. So when you see variables on both sides of your equal sign, you're going to follow these 4 simple steps. You're going to obviously distribute if you're able to. And then, as always, you're going to combine like terms. Make sure when you combine like terms, those mean terms that are on the same side. You can't, if I have like 3r plus 1 equals 2r minus 9, you can't combine 2r and 3r. They're on different sides of the equal, so you can't put them together. Once you combine all your like terms, you should never have more than 2 items being added or subtracted on each side of your equals. That means that if you have r plus 3r minus 2 minus r minus 6r equals blah, 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 blah. Once you simplify all of this, you should have no more than 2 things. One thing will have a letter and the other will just be a number. Once you have combined your like terms, you're going to either add or subtract a group of variables from both sides of the equation. So I always work with variables first, and then I work with anything else I have left over. And once you do that, it's like the problems we did in our last lesson. It just follows in order until we solve it. The biggest thing is when you show your work, especially as these problems get longer, you need to make sure you're staying organized. What that means is your constants, which, by the way, constants are numbers with no variable. You want to make sure that your constants get stacked with constants, and any variables you have get stacked with the same variables. What that means is I don't want to see something like 2r minus 3. Okay? You're stacking terms that are not like terms. You're stacking a constant 3 with a variable expression 2r. You're not allowed to do that. So with that in mind, let's just go right into it. So example 1, we're going to obviously distribute, and we're going to get 8r minus 32. And then yes, we are going to distribute a fraction. 1/7 times 49 will actually come out to be 7. And 1/7 times 70 will actually come out to be 10. So there are no like terms on either side. So I'm going to pick either 7r or 8r and subtract them. So let's work with 7r. And you're going to have 1r minus 32 equals 10, and then it's pretty simple to solve after that. So our next problem, we don't have any distributing to do. There are no like terms to combine, so you have to pick 8p or 10p. Let's say you want to use 10p. It's positive, so you're going to subtract it. So you're left with a negative 2, a negative 2p, and a minus 1. So if you notice, I stacked my p's with p's, and they're all nice and neat in the correct columns. You want to make sure you keep that up. So I'm going to add 1 to both sides of my equation. And we get negative 1 equals negative 2p. And then we're going to divide both sides by negative 2 so that p is alone. And we get p equals a positive half. So I want to talk about multi-step equations. We have variables on both sides and we have fractions, because as we've learned, some of us are not fans of fractions. Now you will have to be able to add and subtract fractions, but I will teach you a little trick. If you choose not to work with them, you actually can eliminate them. So in order to eliminate, you're first going to find the LCM of all the denominators. So if you have 1/4, 1/6x, and let's say 1/2, your LCM is going to be 12. So you have to take into account all the denominators or the trick's not going to work. Once you do that, you're going to insert parentheses around both sides of your equation. So if there's 15 things over here, you're going to put parentheses around all 15. That's what that means. Once you put your parentheses around both sides, you're going to put your LCM outside your parentheses. All right, once per side. After that, you just kind of solve the equation like normal. So in our first example, these are the same problem. We're actually going to not use the shortcut for example 3. We're not going to eliminate the fractions. We're going to do it longhand. So I'm just going to quickly change this to a half s plus 1, a fourth s minus 6. So you can pick, there's no distributing, no combining like terms, so you can either pick 1/4 or a half. I'm going to pick a fourth. So I don't even need a common denominator because I can think of this. Half a dollar is 50 cents. 50 cents, take away a quarter is a quarter. And then we're going to subtract 1 from both sides. And I'll have to finish it up here, I'm out of room. And then we're going to multiply by the reciprocal of the fraction. So we know the answer is going to be negative 28. So let's go ahead and try this fraction elimination step that we learned. So just let's put a 1 out of habit with the s up top. All right, so the LCM of my denominators are 2 and 4 would be 4. And by the way, any multiple works. We could have 8, we could have 12, 16, so on. But the higher the number, the more work you have to do. So try to keep it small. And we're going to just simply put our 4 outside our parentheses that we inserted. All right, and now we're going to solve like this was the original problem. So you need to distribute 4. 4 times a half is 2s. 4 times 1 is 4. 4 times a quarter is 1. And 4 times 6 is 24. And now it looks much friendlier because we don't have to add or subtract any fractions. So I'm just going to pick 1s to undo here. And I get s plus 4 equals negative 24. And then we're going to subtract 4 from both sides. So sometimes this trick does really help us out, especially when we get to our linear equation unit. When we have to graph lines, that trick's going to be really handy. There's 2 special equations we need to talk about. Some equations actually have no solution, whereas other equations have an infinite number of solutions, so we'll just call them special equations. So we call them special because they have special answers. If you look at example 5, we're obviously going to start by distributing 5. So that I have 2m plus 5 equals 5m minus 35 minus 3m. And then I'm going to combine my like terms. So I don't want you to write plus 3m plus 3m. Combining does not mean to do that. It means simply put together. So 5 minus 3 gives me 2m. And then I'm going to obviously subtract off my 2m from both sides. The problem is they both make 0, so don't write m, don't write 0m, they just go away because 0 is nothing. And you're left with 5 equals negative 35. So when this happens to you, don't freak out. That just means that you actually were given the task of solving an impossible equation. This equation has no solution. There is nothing that I can put in for m that will ever make both sides balance out. So when that happens, all you have to do is write no solution. You could write a 0 with a slash through it. They mean the same thing. So both of those answers are fine. So we're going to take a look at what infinite solutions looks like. So again, we're going to start by distributing. And I'm going to combine my like terms. Oops, I meant to write 3 there. And you can keep going if you want, but I just kind of freeze because you look at both sides of this equation, they're the exact same. So what's going to happen is the 3 r's are going to just be eliminated, and you're going to be left with -2 equals -2. So when that happens, that means that you actually have infinite solutions. We can also call this identity. So identity property means I have the same thing on both sides, so you could call it that. You could just draw an infinity symbol. You can write all reals. Any real number will work. So you can try pi over 2, -100, -2000. All of them will work for r. You're going to get the same thing on both sides. So it doesn't matter what you pick, it's always going to work out.